Hello everyone. Today we'll break down 3 common mistakes made with Newton's laws that you'll see in physics exams and competitions. So mistake number 1. Mistake number 1 is that the normal force is not always equal to the weight. So what does that mean? Okay, so let's see when the normal force is equal to the weight. So we have our object and it's sitting at rest, and we have our force of gravity which acts downward and is equal to the weight of the object mg. And it's sitting at rest, so that means we know that the normal force, which is the force of the surface that pushes back up on the box, it's equal to the weight. They're both equal. So that's when normal force is equal to the weight. Now let's see the mistake that when normal force is not always equal to the weight. So let's say you're in an elevator and you have the force of gravity acting down on you. And let's say the elevator is moving downward, and you have the normal force from the surface of the elevator pushing back up on you, Fn. So we know the force of gravity is given by the formula mg, mass times the acceleration due to gravity. And let's say that the force that the elevator is moving down with is F, which is equal to ma, which we know by Newton's second law. So what is the normal force now? So we can see that the normal force is counteracting both the force of gravity, and the force of the total force, which is the elevator going downward. So how do we write that? That means Fn is equal to Fg, force of gravity, plus F. And just evaluating this, it's equal to, by plugging it in, mg plus ma. So when an elevator moves downward, you tend to feel heavier than you actually are because there's more normal force needed to counteract your weight. Okay, let's see when the elevator is moving upward. Elevator, person, and force of gravity acting downward. Fg is equal to ma, and the normal force pushing upward, and the elevator is now moving upward. F equals ma. So what is the new normal force? So the normal force here, the force that the elevator is moving up with is working with the normal force to counteract the weight force. So that means that Fn plus F, they're working together to counteract Fg. So Fn is equal to Fg minus F. And we can see that makes sense because now we have Fn working with another force to counteract the gravity. So the normal force is now less than the weight. Okay. Now let's see mistake number 2. Mistake number 2 is about Newton's third law now. It's not really a mistake, it's just a misconception. But it's pretty important. Mistake number 2. Okay. So let's say, first let's revise what Newton's third law is. So let's say you have a force acting on an object. That means due to Newton's third law, which states that every force has an equal and opposite reaction force, the object will exert a force that's equal and opposite to the person that's exerting the force on the object. So what does this mean? This means that the guy's exerting force on the object and the object is exerting the force on the guy. So what is the misconception here? Sometimes people get confused. Why does the object move if there's a force that the object's acting on the person? Why does the object even move in this direction? It's because these two forces are not acting on the same object. They can't cancel each other out. Yes, the person will feel it hard to move the object, but that's because of the force that the object is putting on the person. So what does that mean in short? It just means that the forces due to Newton's third law don't always cancel each other out. Okay, that's just a small misconception made with Newton's third. Now let's see the last mistake number 3, which is about ignoring net force. And this has to do with Newton's second law. So what is net force? F net, so let me write that clearer. F net is equal to mass times acceleration. So this is just Newton's second law. Newton's second. But what is the mistake that's made with this law? So we have a box that's moving right with a force of 10 newtons, and we have friction that's opposing the motion of the box, acting in the opposite direction, and the friction force is 4 newtons. And the box has a mass that's equal to 2 kilograms. And we want to find the acceleration. Okay, so from given what we know right now, so we know some forces, and we also know the mass, but we need to find the acceleration. Okay. So the mistake here that's made is that some people just plug in the force to be 10, the force that's acting in the direction of the object. But we can see that there's a frictional force that's counteracting that force. So the net force, which means the sum of all the net force, which means the sum of all the forces acting on the object, it can't be just 10 because the frictional force is opposing it. Okay, so how exactly do we find the net force? We subtract the forces, 10 minus 4, because the frictional force is taking away from the force that's pushing the box to the right direction. And that is now equal to its mass times acceleration, which is mass 2 and acceleration we have to find. So we get 6 is equal to 2a divided by 2. A is equal to 3 meters per second squared. Our acceleration is 3 meters per second squared. So from what we've learned out of all of these 3 mistakes is that all of these mistakes can be solved, they can be fixed in one simple manner. You just draw a free body diagram. What is a free body diagram? It's just a diagram that shows all of the forces acting on an object. So here, this is our free body diagram. We show all the forces that are acting on the object, and we can easily see that what force to subtract and what's acting in what direction. Here we can see that the force pairs don't exactly cause the object to cancel out. Here we can see that drawing a free body diagram helps us because it helps us sum the forces that are acting in different directions, and it just makes it a lot easier to tell the normal force. So yeah, all of these mistakes can be fixed just by you drawing a free body diagram whenever you're solving a problem. And that is it. If you didn't understand some of the Newton's laws, I have a video. I have 3 videos on each of its laws. Thank you for watching.